Hello ladies and gentlemen, and welcome back to the channel. Today we'll be making a little instantiating test with the new ECS tools released by Unity and compare it with the traditional ways of instantiating objects. You will need to have Unity 2018.1 or higher for this to work. So as you can see, I already took the liberty of creating the normal version, the traditional way of doing things. So what I've basically done was created a plane that will act as our ground. And here I have a map with a map holder, which will contain the object that we will spawn. And we also have a canvas that holds two buttons, the one used to generate our objects and one that will despawn our objects. So we can see the times for each situation. As our spawning objects, I'm going to use our previously created models, which is the low poly tree. And I've also created a very simple script to generate this map of objects. So it takes a prefab, it takes the map holder, and it takes 2 dimension for a matrix of objects that we will create. We'll also need a list to contain all the objects that will be spawned so we can easily destroy them afterwards. In the spawning function, we have 2 floats, a start time and a stop time, so we can calculate the amount of time it takes to generate those objects. We instantiate the start time with the real-time scene startup at first, and then we start generating the objects by using a formula to create a position for each object, and then instantiating the object at that position. And also, of course, adding it to the list so we can despawn it later. After we do all this, we record the stop time and we make the difference so we can see how much it took to spawn. We also have here the clear function, which destroys the objects, and it functions pretty much in the same way. We record the start time, we destroy the objects, we record the stop time and make the difference. Okay, so we can have a look at it, how it works. So if we go to the map, we can choose how many objects we want to spawn on the x-axis and how many on the y-axis. I've chose 100 and 100. So 100 times 100 should be like 10,000 objects. We'll just spawn 10,000 objects. And let's hit play. And let's press generate map. And if we look at the console, we can see it took 1.46 seconds to generate those objects. We also can clear them. And it takes 0.46 seconds to generate the map. What I forgot to mention is that this works because we know that this is linear and it's all those objects are spawned on the main thread, and this entire loop is made on the main thread, so it waits. We can calculate the time like this because it has to wait to spawn the object before it gets here. Okay, so now what we want to do is start making the ECS version. So let's open another Unity project. Let's actually create a new one. Let's say ECS test and say create object, create project. And now for the project to work with the ECS tools Unity created, we have to make sure some things are set. So we need to go to edit, project settings, player, and in the other settings tab, we have to make sure we are using .NET 4. it will ask us to restart the project, and let's say restart, right? Now we also need to go to the projects folder. We can do that by pressing right click on the assets and say show in Explorer. And now we can see the projects folder. Going to packages and open this manifest.json. I will open it with brackets because I have that program, but you just open it with Notepad. That's no problem. And go to the link that I linked down below in the description, which should be here. It's somewhere on GitHub, and copy this into the manifest folder. There we go. We just put it here and save it and close the file. Now we wait for Unity to update. Okay, now let's delete this folder that Unity created with the project. Now what we need to do is create some of the objects that we had in the other project, like the ground and the canvas. So let's just create a button which should automatically be put under the canvas. Let's call this button generate map, and also has the text generate map. There we go. Let's just put it in the corner. If I manage to grab it, there we go. Let's make a duplicate and this be clear map. Also the text clear map. And let's put it here. There we go. Let's also create the ground. We go to 3D object light. Anyway, we want it to be on the ground, so 0 here as well. Let's make it a lot bigger. Let's say 1000. Anyway, let's create a material for it. Ground. Let's make it maybe some green and apply it. There we go. We'll also need the tree from the other project. So let's just grab it and grab it in here. Let's grab also the material we used for the tree and the texture. And let's make sure the material has the texture on it. And that the tree has the material on it. There we go. Hit apply. And we have it. Now we'll need to make a prototype, which is basically a little bit like a prefab, but for the ECS version. So we'll just say here create empty, and let's call this tree render prototype. And we'll need to add a few components for it to work, like the game object entity component. And we'll also want to add a mesh instance render component, which we will have to add a few things in here, which we can find here, tree mesh, by pressing this, and the material we're gonna use, the tree material. And we also have a few other options here, like casting shadows. So let's say it's gonna cast shadows, but it's not gonna receive shadows. Anyway, there we go. Now we also want to make the map. So let's create another game object and say map here. This is gonna have a component on it which will contain the X and Y dimensions of our map. Basically how many trees we want to spawn on the X and Y axis. So we'll have to create a new C# script. Let's first create a folder and say scripts and put it inside it. And let's call this map instance component. And let's open it in Visual Studio. We're not going to need any of those in here. So let's just delete everything up here. We are going to need to use the new unity.entities and maybe system. Let's also create a namespace for our project. Let's call it ECS test. And now we'll have to create the component. So it's gonna be a struct called map instance. Let's call it map instance, and it's gonna be an iShared component data, which is gonna have two variables, an X and an Y for our matrix. And now this is gonna be represented by a class called map instance component, which is gonna be a shared component data wrapper for map instance. And that's it. And now we're just gonna add to our map the map instance component. There we go. But to be able to actually modify those values, we need to add a tag here to our map instance called serializable. And now the values should be exposed in here as serialized data. So we can change the values in here. Let's put 100 and 100 for now. Now, the next step is to create like a bootstrap for our system, which will boot the entire system, because we don't actually have a start and an update method when we're working with the ECS. So let's just create another C# script. Let's call this one Bootstrap. And we don't actually have to add this one to anything. We just have to have it in here. And let's open it. Okay. So first of all, we'll need to use a few of the other libraries. We'll need to use unity.rendering. We'll need to use unity.entities, and we'll need to use unity.transforms. This will do for now. Let's again create the namespace, use the namespace we already created, ECS test, and we'll need to create this is a standard procedure of how Unity does things at the moment. Keep in mind this is testing and it's very early beginning. It may change in the long run. So we'll just have to create a public sealed class called Bootstrap. And first of all, we'll need to create like an entity archetype, so that will help us to spawn objects a little bit faster. Entity archetype, let's call this tree archetype because it's gonna be for the tree. We're also going to need a mesh instance renderer, which will actually instantiate the mesh of our objects. And let's call this tree look. So I'm basically using their sample as a model for what I'm building here. So I can't fully explain everything that they're doing in here at the moment, but we'll just have to go with it, and it's not a very difficult code to understand. So just go with it, and it's gonna come easier for you with time. Okay, so now we also need an initializing method. Let's call it initialize. And for this to be, and we need a tag for this, which is runtime initialize onload method, which will contain runtime initialize load type before scene loads. So this is basically a tag that tells when to execute this function. In here we're going to have to create a manager, an entity manager, which we're gonna call entity manager, and we'll use world.active.get or create manager, an entity manager, and afterwards let's initialize the archetype, which is going to be tree archetype. And here, if you have more complex objects, you can create components. You can add different components to it, but we're just going to use the position component, so we can set it somewhere, and the transform matrix component, which helps the renderer to render the actual object into the scene. So we'll just say create archetype and say type of position and type of transform matrix. There we go. Now we'll also need another initialize function. So let's say runtime onload method, runtime initialize load type after the scene loads. And this is gonna be called, and this is gonna be public static void initialize with scene. Let's call it initialize with scene. So in here, we're just gonna create the look for our rendered scene. And we're gonna need another function for that, which is gonna get the look of the prototype, which is gonna get the actual prototype we've created in the scene and create from it a multitude of instances. So let's say private static mesh instance renderer, and let's call it get look from prototype. And we're gonna use the name of the prototype, the name of the object in the scene to get it from the scene. Let's call this proto name. And now let's get it with game object dot find its name. And now after we got it, we just need to get the mesh instance renderer component that sits on it. So let's say proto.get component. This is all basic stuff. Mesh instant render component dot value. And now we can destroy the object. We can destroy the object from the scene because we're not going to need it anymore. We got what we needed from it. And we'll return the result. There we go. So now in here, when we initialize the tree look, which we declared up here, it's going to take the result from this function, and the object in the scene, it's called tree renderer prototype. So let's see, tree renderer prototype. There we go. Now we also want to initialize the HUD in here, the HUD system, but we haven't created it yet. So let's create that as well. So we're gonna need a HUD system which will contain the buttons we need. So let's open this. Okay, so what we'll need in here is again to use unity.entities and use Unity engine and maybe Unity engine.ui as well, because we're going to work with the UI. Okay, let's put our namespace again, and inside here let's create the class HUD system, which is a component system. And as you can see, it tells us there's a problem. You can say just fix it. The problem was we didn't have onUpdate method, which is mandatory for this type of class. We just put it down here. We don't actually need to put anything in it. And now let's use two buttons. Let's declare two buttons so we can use them. And one is going to be generate map, and the other one is going to be clear map. There we go. And let's create a function called setup, for example, in which we'll going to find, we need to find this button. So let's say GameObject.find, and let's say how is the button called? I think it's called generate map. Yes, generate map dot get component button, and the same thing for clear button. I think it's called clear button. There we go. All we need to do is add an event listener which points to a function in the Bootstrap part of the system. So let's say generate map dot onClick dot add listener, and let's say Bootstrap dot generate map, which we don't have at the moment, but we're going to create later on. And same here, only we're going to call this clear map, and it's the clear map button. There we go. So now we can return to our Bootstrap, and in here in the initialize with scene, let's initialize our system by saying world.active.getOrCreate manager, and this is gonna be the HUD system, and we're going to access setup, so we actually start the system. Now we are going to need to create a spawn system for our objects. That's the next step. So let's create that, and let's call it tree spawn system, and let's open it. Okay, so same in here, we're going to need to use a few other libraries like Unity entities, collections, mathematics, because we were going to do some calculations, and transforms, and I think that's it for now. So now let's put the namespace again, and let's start working on this system. So what we'll first need is the generate map function that we've already created in here. We'll just copy this and copy, and let's paste it here. I don't know if it's gonna be a public function because we're not going to access it externally, so let's maybe make it private. Of course, most of the stuff in here we're not going to need. We're not going to need those because the instantiating process might not take place only on the main thread in this case, so we can't actually know when it starts and when it stops by doing this. So we'll just delete those for now. We don't need to hold the objects in somewhere as well. Okay, what we do need, however, is to find our map. So let's say map equals GameObject.find, and I believe it's called map. Why do we need to find the map? Because we need to take the map size that we have in here in the map instance component. So we'll just create another variable called map size, and let's make it equal to map, and let's get the component map instance component, and we'll take the value from it. There we go. Now we've resolved the issues here that were a problem here, and since this is already has two values, .x and .y, it works directly without doing anything else. What I forgot to do in here is actually create the class for our tree spawn system. And that's why it gives me an error for the function down here, because it's not actually in a class. And there. And of course, now we need to implement the abstract class on update, which is mandatory. There we go. Now in here we'll need to spawn an instance of this object, but because there are a few other commands, we don't need this as well. Sorry, I forgot to mention. And it's also a good thing to use the new mathematics library. So we're going to use a float instead of a vector3, which basically contains 3 float numbers, the same as vector3. This holds to the new math library. And since we're going to need to spawn in here, let's create another function called private void spawn tree. And we're going to need to send to this, we're going to need to send the position where we want to spawn. Okay, so let's say in here, spawn tree at position I don't know why it's tile in there, because it's tree position. I think that remained from a previous version. There we go. So we'll say spawn tree, but of course we have to spell it right. There we go, spawn tree. So in here we need to create the entity by saying post update commands dot create entity, and we'll create the entity from Bootstrap with the help of our archetype, tree archetype. There we go. We'll also need to set up the component of this entity. So we'll say here new, we just need to set the position in this case. New position, value which is gonna take the value of the position we just sent from up there. There we go. And then we need to add the look so it can be rendered on screen. So we say post update commands dot add shared component, and we're gonna add the tree look. There we go. And that's all we need to do, so we spawn the object. Now, what we also want to do is let's create the function that clears the map as well. So let's say private void clear map. And in here, we want to take the entity manager again. So we'll use the create or get command again, world.active.get or create manager, entity manager. And now we're going to take all of the entities and store them in a native array, which is again a new type from the mathematics library, if I'm not mistaken. Oh no, it's from the collections library. We'll call this all trees, and it's gonna be entity manager dot get all entities, just because we don't have other entities in there that we need to worry about at the moment. And now we can say entity manager dot destroy entities and say all trees. And also, after we do this, we want to dispose of the objects, because it's not going to do it itself as it normally does in C#. Okay, now on the update method, we want to tell it when to start and when to stop. But we'll have a bit of a problem here that can be resolved with a few booleans. So we'll use a boolean to signal when you actually press the button. So when you press the button, this boolean is gonna become true, and in here in the update method is gonna start doing the generate map or the clear map command. So let's say in here, let's initialize the booleans. Let's say private bool generate, and it's gonna be false in the start. Private bool clear, which is also false. And we're gonna need two static functions, which will be able to be accessed from here, from the Bootstrap sealed class. We'll call this public void start generate map, and in here we say generate equals true. Let's also remember to immediately make it false after we start the function, so it can't be repeated. Because when we press generate, we want to only make it once, and because it's in the update method down here, if we don't make it false as soon as possible, it might start again. Anyway, we also need the same thing for clear. Let's make this is called start generate, start clear, and let's make clear true, and same in here, clear equals false as soon as possible. In here, so it's say if generate, we're going to start the generate map function, else if clear, we're going to start the clear map function. And now what we want to do is actually, so we'll be able to calculate the time that it takes for this function to do its stuff. We can't do, because it's not linear, we can't do it like we've done it before in the previous example, in the normal example. Since we don't know it's linear, we'll have to wait for the entire frame to be finished and then take the time that it took for the frame to be made and use that as our point of reference. So what we can do in that regard is use another Boolean. Let's call it time calculation. And it's going to be false. And in the frame that the generation or the clearance starts, we're going to say time calculations equals true. Same for this one. And now we're going to be able to know exactly when the next frame comes, we'll know that it's the next frame immediately after, because time calculation is going to be true. So we say if time calculation, then we make it false because it's the frame immediately after, and it can only be true if it's the frame immediately after those are generated or cleared. And we're going to print into the debug log time.unscaled delta time and plus seconds. And this should give us the amount of time it took for the previous frame to render. There we go. So that will tell us how much time it took to spawn those objects. Because it's still doing all of this in one frame, it just might be not doing, it might just be doing it on multiple threads, so we can't actually know it's linear like in the previous example, but we can know it's gonna be done in one frame. Anyway, now that that's done, we can go back to the Bootstrap here, and we need to make those functions that the HUD is going to, the buttons in the HUD are going to access. So let's call this public static. So those are static functions. Void generate map. And what we'll do is access the static functions in the spawn in the system here, which will trigger, which will change the boolean, which in turn will trigger those other functions that actually generate or clear the map. So let's say tree spawn system dot, it should be accessible. Oh, they need to be static, of course, so we can access them without an actual reference to the class. And those needs also to be static, which is fine because we only need one instance of them. We don't need to create like multiple instances. Okay. So in here, now we should be able to access it. Yes, start generate map. And we're going to need the other one, which is clear map, which is gonna be start clear map. There we go. Let's make sure we've named them correctly. Let's save this. Yes, because now they can be accessed. And now we should be able to go back into Unity. And if everything is in place, we should be able to start generating objects. So let's see, we have 100 and 100. Let's press play. Immediately we see that we have a problem here. We forgot to put this somewhere. Let's go back in here and see where it is. Yes, we need another one for our class, which we forgot. And this one was for the namespace. There we go. That was the problem. Let's try now to play it. And let's try to use the generate map. We still have a problem. Now, this problem is very easily fixable. So the problem is the materials we use have to have enabled GPU instancing. So just press the tree material and say enable GPU instancing. And let's try that again. And if we press generate map, we have generated all the trees. And it took 0.31 seconds. Okay, so now let's compare the two systems that we have created. We have the old one and the new one with the ECS values. So let's make a much bigger map. Let's say 1,000. So let's buy 100. So let's make that's 100,000 objects in both parts. There we go. Just so it's exactly the same. And now let's first try the old one, the old version. And let's press generate map. Actually, let's first look at the console directly. And let's press generate map. Okay, so it took 33 seconds to generate 100,000 objects. Let's now clear it. Okay, so it took 7 seconds, 7.1 seconds to destroy those 100,000 objects. Let's now use the ECS version and see how it works. Let's first stop this from playing. That would be a good idea, so it doesn't affect our results. Let's play this one. So we have 100,000 objects in here as well. Let's press generate map. And it took 0.58 seconds to generate 100,000 objects. Let's also clear the map. And it took 0.13 seconds to destroy 100,000 objects. So as you can see, the difference is huge. We can calculate the difference between those results. Let's use a calculator here so we can do it quickly. So 33.92 divided by 0.58. Okay, so to create objects, to instantiate objects is, with the ECS versions, is about 58 times faster. And to destroy objects, 7.18 divided by 0.13, it's about 55 times faster. So about similar, but again, a 50-time improvement in speed in spawning object. That is actually huge. Okay, that's it. Thank you very much for watching. If you like this video, please give it a like or a share. If you want to see more content like this, please subscribe. And if you have the possibility, please consider supporting me on Patreon from just $1 a month. See you next time.